Hello everyone. In this video, I will be discussing the third learning objective of week 8, t-test. So as I previously mentioned in the first video of this week, that t-test is used when you have interval scale variables, interval or ratio scale variables. So if you want to compare the means of two variables and both the variables are interval or ratio scale variable, then we should use t-test. This is one. Another is it's also possible that we have one ratio scale variable, interval or ratio scale variable, and we divide it into two groups and want to compare the mean of the two groups, then we also use t-test. Okay, so again I say if you have two variables and both the variables are interval or ratio scale and we want to compare mean. For example, you have income level and expenditure, and you want to compare if the mean income level and mean expenditures are same or different. Since both are ratio scale variable, we should use t-test. On the other hand, it's also possible that we use t-test when we have one interval or ratio scale variable divided into two groups. For example, we have income level, we divide it into two groups, male and female. Okay, so and we compare that if average income level of male and average income level of female are same or different, then we also use t-test. Okay, and t-test are two types. One is independent sample t-test, another is paired sample t-test. So independent sample t-test is used when the two variables or two groups are independent to one another. Okay, the example that I gave, the income level of income and expenditure are the same. So they will be, we will be using independent sample t-test here. If you are comparing the average income level of men and average income level of the women are same or different, we will be using independent sample t-test because both the samples are coming from independent categories. There are the two assumptions of these independent sample t-test, that samples are drawn from normal distribution and variances of two samples are same. That means there is homoscedasticity, the variance of two samples. For example, the income and expenditure, or the income of men and income of women, they are similar, and also they are normally distributed. Now, when we use independent sample t-test, look at this question. Is the dependent variable interval or ratio scale? As I already said, that the main variable or the dependent variable has to be interval or ratio. For example, income level. Can the dependent variable scores be grouped based upon some categorical variables? For example, your dependent variable is income level and you divide it between male and female. So gender is a categorical variable. Does the grouping result in scores drawn from independent samples, like male and female, that are coming from independent samples? And last of all, are two groups involved in the research question? So your dependent variable is divided into two different groups. Question is, are these two groups are related to your research questions? So if answer to all these questions are yes, then you should use an independent sample t-test. Apart from this, if you have two variables and both the variables are interval or ratio scale, you also should use t-test. Now, paired sample t-test, as I already mentioned, that if two variables or two groups, categorical groups on an interval scale variable are coming from related samples, then we use paired sample t-test. Just let me give you some examples. Keep it in mind that whether samples are independent or the samples are paired, they are not universal. They might change. For example, if you are testing that if the average income level of male and average income level of female are same across Australia, for example, or across globally, then probably they will be independent samples. However, let's say we are testing that if average income level of male staff is equal to average income level of female staff in Newcastle University. We're still testing the average income level of male and female, but all are coming from Newcastle University. So in that case, probably male and female, these two subgroups will be paired, because since all of them work in the same institution, the income level of man and income level of female will be somewhat related. Okay, so this is sometimes a judgmental decision that the two variables or the two groups we are working on, if they are from independent sources or if they are from related groups. If they are independent, then we will be using independent sample t-test, and if they are from related samples, we will be using paired sample t-test. But the main idea is same. Either both the variables have to be interval or ratio scale variable, or the dependent variable has to be interval or ratio and divided on the basis of a categorical group. Now, example of some t-test results. So this example is based on a hypothesis that the average prices these two religious groups are willing to pay for a particular product is same or different. So actually the idea was to see if the religion has any impact on the average prices the people are willing to pay. So there are two groups, Catholic and Protestant. The number of people in Catholic was 57 and number of people in Protestant were 53. This is the mean price Catholic are willing to pay, and this is the mean price Protestant are willing to pay, standard deviation and standard error. So the main interest is the t-statistic and the p-values. These are the p-values. Okay, and you can say equal variance is assumed and equal variance is assumed and equal variance is not assumed. You can remember one of the assumptions of using t-test is the variance of the samples or the groups are homoscedastic. I mean, variances are same. Now, what we do is, rather than assuming that variances are same, we run the test assuming both. I mean, either equal variance or unequal variance. And if we can show that the results for either assumptions are same, then we can argue that our result is robust to any of this assumption. So look at this t-statistics 0.99 and 0.94 and look at the p-values. They are when equal variance is assumed, it's 0.321. This unequal variance is assumed is 3.347. So both the p-values are greater than the significance level, that's 5%. So we accept the null hypothesis. And null hypothesis was the average price paid by Catholic is same as the average price paid by Protestant. And since we accept the null hypothesis, that means there is no difference. We support the hypothesis that there is no difference between the prices paid by these two groups. Okay, just one point I want to mention here, that if you look at the mean prices paid by Catholic, it is 61, and mean prices paid by Protestant is 50. So apparently we understand that there is a difference. There is a big difference because 50 and 61, it's a big difference. However, when we run a statistical test, our null hypothesis is supported that there is no difference. Keep it in mind that software is a machine. So whatever data you provide and you give some instruction, it will provide you some results. As a researcher, sometimes you need to intuitively understand that if the result is consistent with what you are expecting or not. For example, here you see that there is a difference between the prices paid by Catholic and Protestant in our naked eye. However, a statistical test doesn't show that. What might be the reason? Look at the standard deviation. 43 is for Catholic and 64 for Protestant. That means, I think you remember, standard deviation is the average deviation of individual observations from the mean value. Now here the mean value is 61, the standard deviation is 43, and mean is 50, and standard deviation is 64. So a higher standard deviation indicates that the individual observation are much deviated from the mean value, that might be the reason that the statistical test supports the null hypothesis, but we think that it should not be supported. So that might be caused by some extreme values. Your higher standard deviation indicates that probably there were some outliers which has influenced this result. So when you have this type of situations or this type of scenarios, probably you go back and look at your data, that if there are some extreme observations, then one strategy could be get rid of this extreme observation and then re-estimate the model again or test the hypothesis again, and probably you will be able to get the result you are expecting. This is an example of a paired sample t-test. So in this case, what was tested that whether a person will be willing to buy their engagement ring from a store, from a conventional store, or from an internet store. So this is the proportion of the number of customers indicated that they are willing to buy it from a conventional store, and this is the willing to buy from internet store. And when the t-test was run, look at the mean and t-test and p-value. Its p-value is 0. So a p-value 0 means it is less than the significance level 5%. So we convincingly reject the null hypothesis that the people are equally favorable to both the conventional store and internet store. We reject the null hypothesis, and we see that people have clear preferences to buy their engagement rings from conventional stores rather than internet store. Okay, so these are the examples of independent sample t-test and paired sample t-test. Keep it in mind that in your second assignment, probably you will need to run the independent or paired sample t-test. So I will suggest that you read the supporting materials from the textbook, solve the workshop questions related to today's lecture, and develop your understanding so that you can answer the related question in your assignment too. Thank you very much. Please see the next video for a discussion on the next learning objective of this week. Thank you.